Good morning, all you fabulous fives out there. Lovely to have you with us again for another concentrated lesson. I do find that we go through a whole lot more concepts a whole lot quicker when only the teacher is speaking. It's not my favorite kind of lesson, but I guess that's the way that we're doing things for now. Anyway, I hope that you're learning things from these lessons. And today we're going to do another concentrated lesson looking at something that I find quite useful. I think that you'll find it useful in the long run. There are a couple of times you'll use it now, but it's really preparing you for what you will learn later on. And it is something that you are required to know, although you don't use it all that much at a grade 5 level. Anyway. Reminder, if you'd like to email me, it's grade5@worksheetcloud.com. Thank you for those who have emailed. Also, after the lesson, click on the link above, do the worksheet, and that will give you a good idea whether you've understood what it is that we've covered in today's lesson. And what we are covering in today's lesson is divisibility rules. That's how we check whether something is divisible by a particular number. We'll go into that now. I just noticed that divisibility has a whole lot of I's as every second letter, and if we just spelt it with an I on the end, it would be every second letter. Anyway, back to maths. So our goals for today, to know how to check if a number is divisible by 2, 3, 4, 5, 6, 9, and 10. There are rules for 7 and 8. They're just not particularly easy rules, and so I think actually let's rather skip them. They're more complicated than they're worth. Maybe you'll learn them next year in grade 6 or 7, we'll see. And then also be able to see when we might need to know them. So we've got these rules, and why on earth would we need to know them? So those two things. When I say a divisibility rule, what I mean is will one of those numbers fit into the number we're looking at? Exactly. So I think I'll go through all of the divisibility rules, and then, in fact, no, let me do the divisibility rules I'll do them in sets. We'll do the 2, 2, 5, and 10, because they have a similar rule. And then we'll go and look at some numbers, and then we'll do 4 separately because it's kind of its own story, and then we'll look at 3, 6, and 9 because there's a relationship between those rules as well. So the divisibility rule for 2, a number is divisible by 2 if it ends on a 0, 2, 4, 6, or 8. In other words, if it's even, it's divisible by 2. So looking at an example, we will look at some more examples. But does 2 fit into 344 exactly? I don't have to work out the answer, but I do know that because it finishes on a 4, which is one of the numbers, then 2 goes into the whole number. So I know that 344 is exactly divisible by 2. 2 will fit into that. So for 2, it has to end on a 0, 2, 4, 6, or 8. That's all you need to check. So it can be a really long number. You don't need to look at the whole thing, just the last digit. And if that's a 0, 2, 4, 6, or 8, then the whole thing's divisible. Oh, I think I jumped an extra. Yeah, there we go. Divisibility rule for 5. Again, we're only looking at the last digit. We just need to check if it ends on a 0 or a 5. And if it does, then the whole number is divisible. And if you think about the 5 times table, I'll do the 5 times table and listen for all of the numbers that I say and see what they end on. They will either be a 0 or a 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. So they're all either ending on a 0 or a 5. So I gave you the example. If we get the number 1,946,370, and we want to check if that is divisible by 5, I can ignore all of these digits, just check the last one. It's a 0, so the whole number is divisible by 5. If it was a 5, the whole number would also be divisible by 5. 10, this one's even simpler. Basically, if it finishes on a 0, then it's divisible by 10. So if I give you the number 240,291, and I ask, is it divisible by 10? I only look at the last digit. It's not a 0, so it's not divisible by 10. Simple as that. If it's a naught, it is. If it's not, it's not. If the last digit is not a naught, then it's not divisible by 10. Let's jump across to our worksheet. Let me pop in and quickly look at this. This was just our homework, and actually the only thing I wanted to check with our homework, I think the memo is quite comprehensive, and we have practiced that the last 2 days. So the only thing I wanted to check was if you managed to get the message that was hidden, the code, and it was another way of checking if you were correct. So for those of you that didn't do it, the answers were 8, 1, 16, 16, 25, and that's the sort of thing. And if we converted those into letters, so A is equal to 1, the other way around, actually 1 is equal to A, 2 is equal to B, and so on, then you got Happy Earth Day, which was yesterday. So if you did get all of them right, it would have spelled out Happy Earth Day. If you made any mistakes, you would notice some spelling errors in Happy Earth Day. So that was all. That was the message that was hidden in the code. We don't need to worry about that now. Let's go across and have a look at our table. So I've set up a table here. These are all the divisibility rules we're looking at. I'm going to put a few numbers in there, and we're going to check those divisibility rules as we learn the rules. So to start off with, let's put in the number that we're going to look at first. We're going to look at 425. And the only rules we're going to check to start with are 2, 5, and 10. Those are the ones that we've looked at so far. Right, so looking at 2, our rule for 2 is we need to look at the last digit and see whether that is divisible by 2, or if it's 0, 2, 4, 6, or 8. It's not, so 425 is not divisible by 2. Let's have a look at 5. Well, is the last digit, that's the only thing we need to look at, is it a 5 or a 0? Yes, so 425 is divisible by 5. Is it divisible by 10? Well, the rule is if it ends in a naught, it's divisible by 10. That's not a naught, it's a 5, so it is not divisible by 10. So as we finish the first example, I want to take a moment just to look at one thing, and that is I'm not actually solving the problem of 425 divided by something. All I'm doing is to check to see whether it is divisible by that number, so that if that number goes in exactly. And later on in the lesson, I'll show you an example of where you will use this. And I'll mention a couple of other examples, although some of them are things that you haven't done in maths yet, unless your teacher is pushing you really hard and you've done them already. The next number I'd like to look at is 673. Let's look at 2. Does it finish in a 0, a 2, a 4, a 6, or an 8? No. So the whole number is not divisible by 2. Does it finish in a 5 or a 0? No. So it is not divisible by 5. Does it end in a 0? Nope. So it is not divisible by 10. And this particular number is not divisible by any of the 3 we're looking at so far. I'm going to make the numbers a little bit bigger. 5, 6, 7, 3. Doesn't matter if they're bigger. All right, so I'm actually going to put down the next couple of numbers, the next 2 that you can see on the screen. And while I'm doing that, I'd like you to see if you can figure out if they're divisible by each of those. You can either remember it, or if you want to jot it down on a piece of paper, you can. So I would say that perhaps you would, if you were jotting it down, because you don't need to do your times table like this, you could just say 5, let me make a bit better space, 5, 6, 7, 3, and next to it you could say the things that it is divisible by. So if you don't think it's divisible by 2, don't put it. If you do think it's divisible by 2, then you'll put the 2 there, and the 5, and the 10, depending on whether it is or isn't. So it's quite possible that you'll have nothing written down next to it. but maybe when we do the other divisibility rules, you'll find something. And let me do one more. Right, I'm going to start with those ones, just those 5. Then I'm going to go back to look at the rule for 4. Let's do 2 for all of them. Does it end in a 0, 2, 4, 6, or 8? Nope, not divisible by 2. This one ends in an 8, is divisible by 2. This one ends in a 7, not divisible by 2. So that's quite nice. In a very, very short time, I can see quite quickly that each of those ones in the bottom 3 is not divisible by 2. Yeah, so that's quite useful for me to be able to see without checking, without actually doing the division, seeing whether it can divide. Looking at the 5s, nope, not a 5 or a 0, not a 5 or a 0. So far, 5 has only gone into one of the numbers we've looked at. Doing the same with 10, not a 0, not a 0, not a 0, nope, nope, nope. So none of the numbers we've looked at ended on a 0, and none of them is divisible by 10. Let's look at the divisibility rule for 4. Okay, so 4 is a little bit more complicated, but not hugely complicated at all. So firstly, if the number made by the last 2 digits is in the 4 times table, then the whole thing is divisible by 4. So looking at the first number in the example, does 4 fit into 52,824? I don't need to look at it, do everything with it. All I need to do is look at this number formed by the last 2 digits. So the number formed by the last 2 digits is 24. You can see there it is, 24. 4 does fit into 24. And so that means that the whole number, 52,824, is exactly divisible by 4. So 4 fits exactly in there. I didn't have to work it out. All I needed to do was check the last 2 digits, which is kind of neat. So let's jump back to the table and let's look at 4 for each of these numbers that we've done so far. So remember, we're looking at the last 2 digits now. Let me erase what we were looking at with the other ones. So is that divisible by 4? This is where your times tables are important. So even for the divisibility rules, you need to know your times tables. So 2, 4, 6, oh, sorry, I'm doing my 2s. 4, 8, 12, 16, 20, 24, 28. Nope, 25 is not in there. Not divisible. So the next 2 I notice, and I think that it's really important to start noticing patterns in your maths, is I notice that both of those are 73. So if I just work it out for one, I'll have my answer for both because it's the same number. Oh my goodness. Am I going to have to go with the 4s all the way? Tell you a cheat. I know that 10 times 4 is 40. So let me start there rather than going all the way. 44, 48, 52, 56, 60, 64, 68, 72, 76. Nope, not 73. So neither of those ones is divisible by 4. Let's look at 78. Well, we had 72, 76, 80. Nope, also not. And how about this one? 77, also not. We can see that because it's close and we've been working in the 70s. So we do have none of the ones that are divisible by 4. I know that I've definitely put some ones in the next examples that are divisible by 4. So it's not that they're just never divisible by 4. It just happens that the first 5 examples are not divisible by 4. Let's have a look at 3, 6, and 9. They're part of the same sort of family, which makes sense because 3 fits into 6 and 3 fits into 9. So you can see they're all sort of, there is a relationship there already, and let's go and explore that some more. So in fact, I decided to put them all on the same sheet. I'm just going to pause that. It looks like my example is there. the divisibility rules for 3, 6, and 9. I've put them all together on the same slide because there is a relationship between them. So the sum of the digits is in the 3 times table. When I say the sum, I mean when you add them together. So let's look at the example. Does 3 fit into 735 exactly? I don't have to work it out. What I can do is just add them together and have a look. So when I say sum, I mean add. So 7 plus 3 is 10, plus 5 is 15. 15 is in the 3 times table. So yes, 735 is divisible by 3. 6, basically the same rule as 3, except it must be even as well. So again, I'm not looking at does 6 fit into it. I'm still looking at if I add them together and 3 fits into it. But then I'm also looking at this original number to see if it's odd or even. So it must be even as well as that rule to do with 3. And when I say even, I mean ends on a 0, 2, 4, 6, or 8. So let's check. Is the sum of the digits in the 3 times table? 8 plus 8 plus 8 is 24. And looking again at the original one, is it even? Yes, it is. And so that means that the whole number is divisible by 6. The last one, similar to the 3, but this time we've got to add them together and see if the answer is in the 9 times table. So for example, if I've got 891 and I want to see if it's divisible by 9, I go 8 plus 9 plus 1. So I'm using the associative law and saying 9 plus 1 is 10, plus 8 is 18. 18 is in the 9 times table. And so yes, it is true that 891 is divisible by 9. Let's go have a look at the examples we've done so far and let's check them for the divisibility rules. Here we go. Let's check the first one. Is that number divisible by 3? So I'm going to just do it on the side here. 425. So I'm going to go 4 plus 2 plus 5. So that's 6. That's 11. 11 is not in the 3 times table. So that one is not divisible by 3. And if it's not divisible by 3, I know it's not going to be divisible by 6. In fact, I also know it's not going to be divisible by 9, but let's check it anyway. If we look, we've already added it up to get 11. 11 isn't in the 9 times table, so that number, 425, is not divisible by 9 either. Sure, it looks like such a nice number, but none of those other ones fit into it. I'm going to work across for these ones. So 673, I'm going to quickly add those together. 6 plus 7 plus 3 gives me, that's 10, plus 6 is 16. 16 is not in the 3 times table, not divisible. If it's not divisible by 3, it won't be divisible by 6. 16 is not in the 9 times table, 9, 18. So wow, this one's not divisible by any of those numbers. Do you remember what it would be called if it was only divisible by 1 and itself? I wonder if you remember the rhyme. If my numbers are 1 and myself, then I sit on the prime number shelf. Let's look at our next number. 5. Oh, I'm going to have to clear some space here. It's a little bit different on my iPad. I see I'm going to be writing behind my picture. So 5, 6, 7, 3. 5 plus 6 plus 7 plus 3. I'm going to group those together to get 10 plus 11 gives me 21. 21 is in the 3 times table. 3, 6, 9, 12, 15, 18, 21. And so it is divisible by 3. Let's look at the original number because we know it's already divisible by 3. Let's check. Well, it's not even because it doesn't end on a 0, 2, 4, 6, or 8. So it's not divisible by 6. Let's check for 9. 9, 18, 27, not in the 9 times table, and so it's not divisible by 9. Looking at the number 8, 3, 5, 7, 8, 8 plus 3 plus 5 plus 7 plus 8. Oh, that's a lot. Okay, well, let me group those together. I can see that makes 15. 15 and 5 is 20. So I've now added those three together. 20, I'll go 8 first, so 28, and then plus the 3 makes it 31. So my total is 31. I hope you could follow what I was doing. I was using the associative law to add in the order that made it easiest for my brain. It was behind my picture. But I was going first those two, which gives me 15, plus that gives me 20. Then I added the 8 to get 28, and then I could count 29, 30, 31 over there. And so I got my answer of 31. And unfortunately, 31 is not divisible by 3. So it also won't be divisible by 6. And 31 is not in the 9 times table either. There we go. Okay. 6677. 6677. 6 and 6 is 12. 7 and 7 is 14. 12 plus 14 gives me 26. 26 is not in the 3 times table, which means it's also not in the 6 times table. I hope you can see why I can do that, because every number in the 6 times table is also in the 3 times table, because 3, 6, 9, 12, 15, 18. So every second number in the 3 times table is in the 6 times table, and that's why I don't have to check it every single time when I'm looking for divisibility by 6. You would need to check it if you weren't checking for 3 as well. It just so happens because they're a family, I'm checking them at the same time. And it also won't be divisible by 9. Okay, I'm going to pick one that will be divisible by a couple of these. So let me pick, oh, we are running out of time. We move down a bit. Just going to pause for a moment. I've added 2 more just for us to check each of the divisibility rules. So we're going to go through those quickly. Then I'm going to do a little bit of in your head work, and then I'm going to show you a magic trick. And if you want to know how to work it out, you'll have to watch again tomorrow. Okay, I'm going to check 2's first. So the last number for both of those is either 0, 2, 4, 6, or 8. So both of those are divisible by 2. I'm going to check 4 next. 72, so start with 40, 44, 48, 52, 56, 60, 64, 68, 72. Yes, it's that one is. 62 wasn't in that timetable, so that one isn't. I'm going to look at 5 and 10 next. Does neither of these end on a 5 or a 0? So neither of those are divisible by 5, and likewise they're also not, they're also not divisible by 10. So let's check the 3 that we're focusing on. So for this one, to check for 3, I've got to add them all together and see if it's in the 3 times table. So I'm going to do it out loud. Follow with me. So 4 plus 5 is 9. 9 plus 3 is 12. 12 plus 7 is 19. Plus 2 is 21. 21 is in the 3 times table, so yes, that is divisible by 3. Now, because the whole number was divisible by 3, I now, for the 6, just need to check the last number. So it is divisible by 3, plus the last number is an even number, which means it is divisible by 6. For 9, I got to 21. 21 wasn't in the 9 times table, so that one's still not divisible by 9. Looking at this one, I'm going to do it out loud. So 9 plus 9 is 18, plus 9 is 27, 28, 34, 35, 36. 36 is 12 times 3. It's in the 3 times table. There we go. You must know your times tables. it's in the 3 times table and it's even, so it's divisible by 6. And 36 is also in the 9 times table, and so it's divisible by 9 as well. Why do we need these? What is the point of these? Where are we going to use this in maths? I don't know how well you remember or whether you watched this particular lesson, but we did a lesson. Okay, just wanted to check we're in the right place. We did a lesson on factors, and we did these factor trees. And we maybe had something like that, and we were needing to find out what are all the numbers that fit exactly into 36. And we always knew that 1 and itself fitted into everything. But now I can use my divisibility rules to check to see whether everything goes, whether there are things that go into there. So I'm not going to do all of them, I don't have time. But for example, I can see that 3 plus 6 is 9. So I definitely know that's in the 3 times table. So 3 with something. It's in the 3 and it ends on an even number. So 6 definitely goes in there. It's also in the 9 times table. So 9 definitely goes into there. And so you can see I've already picked out those 3 factors just by knowing the divisibility rules without having to have done any. I'm not saying those are the only ones. I could, for example, say, is that in the 4 times table? Yes, it is. So 4 goes in as well. And you can see how I can match up. And then I just need to find the partner. So I can ask myself, how many times does 3 go into 36? 12 times. How many times does 4 go into 36? 9 times. How many times does 6 go into 36? 6 times. How many times does 9 go in? Well, yeah, 9 goes in 4 times. I've actually done that both ways round. I only needed to do one. I was just looking at the divisibility rules. And in fact, there's another one as well that's even. So 2 goes in because it ends on a 6. 2 goes with 18. All right, so that's one place you'll use it. You'll definitely use it in simplifying fractions. I don't know how much you've done of simplifying fractions, but that's something that will come in when you multiply fractions next year or the year after. You'll learn about it. So definitely loads of places you'll use it in maths, but it is important that you know the divisibility rules. So I have just enough time for my magic trick. So each of you, I'd like you to think of a number, make it an easy number, somewhere between 1 and 10. And this is for you, not for me. I'll still be able to figure it out. So I'd like you to think of a number. I'm going to do an example just so that you can follow with, but you obviously don't choose the same number. So I'm going to choose the number 4, but you choose a different one in your head. Okay, so I'm going to ask you to think of a number. You can write it down so that you can do this. I'd like you to add 1 to that number. So now I've got an answer of 5. Now I want you to multiply your new number by 9. Might take a little while. Practice your times table. I'll put my answer down here. Right, whatever your answer is that you've got now, I want you to add the numbers in the answer together. So for example, like we were doing for practicing the divisibility rules. So for example, if I add those together, I get 9. But let's say I had 274, and I added those together, and I got 2 plus 7 is 9, plus 4 is 13. I still want you to add those two together until you're down to 1 digit. So in my example, it was just 1 step, but in this example over here, I had to add it a couple of times. So I hope you understand what I mean by adding the numbers in your answer together until you've got 1 digit left. So that's what I'd like you to do. So just to recap, you started with a number. I said, let's make it between 1 and 10, just to make it nice and easy for you. You added 1 to your number. You took your new number and you times that by 9, and you got an answer. That answer, I want you to add together the numbers in the answer until you've only got 1 digit left. I think it'll just be 1 step for you. Right. Your new answer, I'd like you to subtract 2 from that answer. And then think about your answer very hard. Yes, I'm thinking. Yes, I'm getting it. I can pick it up. Your answer's 7, isn't it? If you'd like to know how I did that, you're going to have to watch tomorrow. And if you didn't get 7, you made a mistake. I'll do it again tomorrow with a different one. So, reminder, if you have any questions, except on how that trick works, I'll teach it to you tomorrow. Just email me, grade5@worksheetcloud.com. And remember, after the lesson is finished, click on the link above, do the exercise, the worksheet, just to make sure that you've mastered the divisibility rules, which will become very useful to you, speeding up your maths later on in your school career with maths. Have a fabulous day, grade 5s. I look forward to seeing you again. Goodbye.